Volcanoes by Sandra Markle. One ordinary April day, something special happened. Hot liquid rock exploded from a volcano in Iceland. Once in the air, the bits of liquid quickly cooled and turned into ash. Then the volcano kept on erupting. Soon the air was full of ash. Nearby, a dairy farmer herded his cows into the family's big barn. His wife said, "It was scary. I could hear the volcano rumbling like distant thunder." Soon, even though it was day, it was dark, and there were flakes falling from the sky. These were not white snowflakes, though. The flakes were black. When they touched my skin, they felt like sand. This volcano's eruption had a big impact on the local people and others around the world. So why did the volcano erupt? Compared to the whole Earth, the Earth's crust is thin. The crust is broken into pieces, like a cracked, hard-boiled egg. Each piece is called a plate. Deep inside the Earth's core is so hot, the rock around it heats up and moves. As the rock heats up, it rises. Near the crust, the rock cools off. Then it sinks. Scientists think these currents make the plates move. When the plates move, melted rock inside the Earth rises. This melted rock is called magma. Here shows the plates on the Earth, and the red is the in-between, like the cracked parts of the eggshell. Below the ground and water, the Earth's crust is broken into plates. Plates are on the move, but we can't feel it. The fastest plate moves just 6 inches a year. Now over here it says, see magma for yourself. You can model what's happening to the magma under the Earth's plates. With an adult's help, boil water in a pot. Drop a handful of raisins into the water. Watch, you'll see the raisins sink and rise. The water heats up at the bottom of the pan and rises. It cools at the surface and sinks. The raisins ride the currents. The currents move the magma under the Earth's crust in a similar fashion. If the plates move far enough apart, magma reaches the Earth's surface. Magma may explode into the air. It may flow onto the Earth's surface. When magma flows, it is called lava. Lava flows out at different places around the world. If a lot of lava flows out at one spot on the Earth's surface, it forms a mountain, a volcano. Many are along the edge of the Pacific Ocean. Here's the map. Here shows the Pacific Ocean. And here in this section is where most of the volcanoes are. The red dots are really big, famous volcanoes. Many are along the edge of the Pacific Ocean. No wonder it is said to be the Ring of Fire, because it makes almost a circle here. It's called the Ring of Fire. It's where the world's most active volcanoes are all around that area. If the lava is stiff, it piles up on the Earth's surface and forms a cone-shaped volcano with steep sides. The volcano that erupted in Iceland is a cone-shaped volcano. It is not very active. Its last eruption was almost 200 years ago. While it was inactive, a lot of ice built up on the mountain. Then in 2009, scientists discovered the volcano was becoming active again. And this is a photograph of the volcano that erupted in Iceland. There are two shapes for a volcano. This page talks about a cone-shaped volcano. Here, I'm going to read the caption first. Here, Magma fills a chamber inside the volcano. Then it pushes up a pipe-like part at the opening of the surface, the crater. So the crater is kind of like a hole, and then the sides kind of build up. Here the magma is exploding out as lava. It kind of builds up right there. Scientists know a volcano is getting ready to erupt when it swells. This happens because magma pushes up inside the volcano. The mountain does not swell enough for people to see it getting bigger. Special instruments measure the tiny movements of the rocks. Other instruments record earthquakes around the volcano. Lots of quakes are another clue. Magma is rising inside the volcano. The Iceland volcano erupted lava under its ice covering. The ice melted and turned to steam. If you've ever watched steam lift the lid on a boiling pot, you know what happened next. Steam and gas escaping from the volcano blew magma high into the air. The magma exploded into millions of tiny droplets. These cooled and became ash. Winds carried the volcanic ash across Europe. The volcanic ash could damage jet engine parts, so it was dangerous to fly. Airplanes around the world were grounded. Some people were stranded. After the eruption in Iceland, ash covered the ground. And here someone has a handful of ash. It looks a bit like sand, but it's lighter and it's scratchy a little bit. Kind of sand can be scratchy, but it's also powdery. Not just volcanic ash causes problems. Hot lava from volcanoes also creates damage. Flowing lava can destroy buildings and roads. And we see that mostly in Hawaii. The volcano named Mount St. Helens in Washington State once blasted out hot gas and knocked down whole forests. When it erupted, this is Mount St. Helens, a whole side of this volcanic mountain blew off. And when it did that, the air was so hot and supercharged that it made an entire forest lay down, and the trees were all pointing the same direction. It's called a pyroclastic flow. It's really a flow of hot, hot air. Of course, the results of volcanic eruptions aren't all bad. For one thing, the volcanoes build new mountains and islands. In Iceland, scientists discovered the bits of volcanic ash were coated with minerals plants needed to grow. After the eruption, the dairy farmer had a big job cleaning ash off his house and barn roofs. In the fields, though, the grass quickly shot up healthy and green. Soon, there was plenty of fresh food for his cows. Here, a farmer is sweeping ash off of his roof. The ash makes a healthy place for plants to grow. Plants like the minerals in volcanic ash. I hope you enjoyed this selection about volcanoes and are able to think about how volcanoes change the earth. There's a lot of different ways.